All right, I will be a little bit more pinned to the podium than I normally like to be. Tend to walk around a little bit. So my name is Matt Casey. I'm the data science content lead at Snorkel AI. Our flagship product is called Snorkel Flow. It's a platform for labeling data at scale for enterprises. I'm not going to talk a lot about our platform, but I want you to know what it is. We have a construct called labeling functions that allow you to encode whatever heuristic, whatever rule, whatever code, whatever external model makes sense to apply a label. And you can have that, you put together a group of these and we denoise your labels on the back end. I'm telling you this because I also want to tell you that we are a Microsoft partner, and our platform is dedicated to ensuring that our customers have access to the latest and greatest in large language models and cloud compute, which means we are integrated with all the top cloud compute and large language model providers, including Microsoft Azure, Azure Cognitive Services, and Azure Cloud. All right, so on to our topic, evaluating LLM systems. You are all involved in, You are all involved in AI in some way, so a lot of this is going to be things you know, but we're going to establish the baseline, and then we'll move on from there. LLMs do not behave like classic models. You all know this. Classic models produce a value within a constrained space, whether that's a category or a number, and this is much easier to quantify. It's either right or wrong on a record-by-record basis, or it's wrong by some amount, and this lends itself to easy metrics, to accuracy, to F1, to your R-squared. Whatever metric you want to use, there is some nuance, but the math is very straightforward on a record-by-record basis. Generative models do not. They have an unconstrained range of output possibilities. You've all seen this. You've all seen hallucinations from ChatGPT, maybe some funny ones. We can share stories later. So if you ask ChatGPT, who was the 16th president of the United States, it can answer Abraham Lincoln. Correct, right? But there are multiple versions of correct answers. It could also answer the 16th president was Abraham Lincoln, or it could tell you Abraham Lincoln and give you a bio of Abraham Lincoln. Those are all correct, but it's hard to compare all of those against one piece of ground truth. Your model can be right or wrong in many ways. It could be factually incorrect. In this case, it's not. It could be tonally incorrect. Probably not in this case. But the format can be wrong, right? You can hit the right tone, but maybe you have a wall of text and what you want is bullet points. What you want is headers. What you want is something that's broken down into a very short response. Or maybe you want the deep dive. So these are all different ways that your model can be wrong. When you're talking about evaluating a generative model, there is no silver bullet. There are a lot of ways you can do this, but it's all going to be bespoke. At Snorkel, we say that there are three main things to keep in mind when you're talking about generative AI evaluation. It has to be specialized, it has to be fine-grained, and it has to be actionable. I'm going to say those words like 50 times during this presentation. I'm going to drill it into your heads. Specialized, fine-grained, actionable. Specialized, fine-grained, actionable. That's three. If anyone wants to keep count, go for it. So specialized means the evaluation has to work for your application, for your domain, for the things that you care about. Fine-grained means you have to be evaluating it on the things that you care about. You can have a large language model that tells you who the 16th president was. That's great. But you need one that handles a contract dispute or a dispute over payment, right? Knowing who the president was does not help you. Actionable. Knowing that your model is doing something wrong does not help you fix it. You need to be set up in a way where you can go, we have a problem, let's get to a solution. Specialized. So here are some off-the-shelf tools that are useful. They will not get you all the way to production, but they are useful and valuable. Benchmarks. Benchmarks ease the problem by making LLMs behave like classical models. It'll give the model a sentence and say, is this sentence grammatically correct? It'll give the model a paragraph and say, is this paragraph about the show Criminal Minds? In fact, one specific benchmark example I saw recently was a paragraph about Criminal Minds and then asking yes or no, will Criminal Minds be renewed for a 13th season? These are the kinds of things that you can do to constrain this. And then this brings you back to your classic ML evaluations. Is it right Is it wrong? Is it wrong by how much? Predictive models. So for things like tone, there are great off-the-shelf models. I'm sure you're all familiar with Hugging Face. Anyone not familiar with Hugging Face? Let's see. Raise your hand if you're not familiar with Hugging Face. Great, they're doing a much better job marketing than we are. So there are many off-the-shelf models on Hugging Face that you can download and build into your system to detect tone, to detect toxicity, to detect many other things that are valuable to you in your LLM evaluation. And then you have LLM Evaluate. So this is a one that has evolved relatively recently. This might be new to some of you, but hopefully not. This is the idea of, and it sounds a little strange on its surface, asking an LLM to judge whether or not an LLM is doing well. So you're asking the model to judge the model. And basically how this works is you put together a prompt template where you go, here's the prompt, here's the response. Is this response good for this prompt? It gets a little more sophisticated than that in practice, but that is the basic setup. And these will all help you. There are great off-the-shelf versions of all of these that will get you some distance, but some distance does not get you the whole distance. You're all in, this is AI for startups. Raise your hand if you're at a company that's using AI. You don't count, you came with me. Okay, so roughly half. So you know what your production metrics are, right? And your production metrics are going to be different depending on your application. If it's an internal copilot, you know, your accuracy can be a little bit lower because you have a human in the loop that's going to fill the gaps for you. If this is going to customers, that's very high. So here are some common evaluation criteria, and accuracy, pretty obvious. Is it factually correct? You have toxicity, fairness, robustness, explainability. These are all very useful metrics across all kinds of different enterprises. But already in this, we have some new ones. Is anyone here at a healthcare company or healthcare related? Okay. So I don't know what your company does, but it might refer to anatomy at some point, right? And that might trigger a toxicity filter, which you don't want. You need to communicate with the user about anatomical body parts, right? Anyone here doing fintech of any kind? Okay. That was a very shy hand. Are you sure it's fintech? So fairness is different in fintech, right? And then we get into compliance and competitors. This gets very bespoke very fast. Healthcare, very different compliance from fintech, very different compliance from marketing at a CPG company. Competitors, this one is definitely going to be bespoke organization by organization. Snorkel's competitors are very different from Microsoft competitors, right? And there's no off-the-shelf model that's going to do that for you. There just isn't. No off-the-shelf model is going to filter for your competitors. And you really don't want a customer-facing LLM to mention your competitors. Cigna does not want their customers hearing about a better deal from Blue Cross. That's not going to make Cigna happy. So these are things that you need to align your model on. So at Snorkel, we take a more aggressive approach. That's a more bespoke approach. Now, I mentioned labeling functions before. This is one of the places where we use labeling functions. Heuristics are a good place to start. You would create a simple function that says, hey, in the case of competitors, here are the list of all the companies that we think are competitors. If any of those companies appears in a response, reject it. Very simple, very straightforward. These can get a lot more complicated, but this one, very straightforward. Predictive models. We talked about predictive models before for toxicity and fairness, and how there's already some nuance there, right? So you could take your off-the-shelf predictive model for tone or toxicity, and you could customize it for your organization. Again, different organizations are going to have different ideas of fairness and toxicity. Fintech company is going to have a very different idea of what's a positive tone from the marketing department at Oreo. Oreo is going to be very bubbly. In fintech, it's going to be a little bit more sedate. Prompt engineered LLMs judge. So LLMs judge we talked about before, off the shelf, will work for a generalized audience. You don't have a generalized audience. You have a specific audience with specific needs. So you work with the prompt to really get it to upgrade it to what you need for your specific application. And this is actually much more effective than it sounds. It is also maybe more work than it sounds, but it can be, you can build up your LLM as a judge to be a pretty good proxy for your SME. And actually, speaking of SMEs, back on the predictive models, a thing at Snorkel that we do a lot is we create what's response quality models. And these are neural networks that act as proxies for the SMEs. And we do this through, we'll label 5,000, 10,000, 20,000 examples using these labeling functions. The beautiful thing about these labeling functions is you define your heuristics and you apply it to your entire data set. So once you have your idea figured out, you can think of them as rules, but it's more complicated than that. But you get your rule figured out, and boom, you label the entire data set. You come up with your 5, 10, whatever, however many rules you need. Every time you change one, boom, you relabel the entire data set. The last thing that you need is ground truth, right? None of this is going to solve itself. AI is not going to solve itself, at least not for the foreseeable future. Is AGI on the horizon? We can argue later. So one step in this will be having your domain experts annotate a small amount of data, not a lot, 100 rows collectively, 100 responses, and then you can use that to gut check everything else. If your LM as judge is accepting, sorry, I keep eating this mic. If your LM as judge is accepting 70% of responses and your SMEs accepting 70%, and your SMEs are only accepting 30%, you have a gap and you need to fix it. And this stage lets you figure out what you need to tinker with here. So why are we tinkering with all this? Because we need to apply it across the tasks that you care about. So fine grained, remember, specialized, fine grained, actionable, specialized, fine grained, actionable. I think I'm up to 6. So fine grained means you need to evaluate the LM on the things you care about. This is a pretty chart. It's also pretty useless. 74% accurate, great. On what? It gets president right 98% of the time, and it gets your customer service complaint right 10% of the time. That's a problem. So you need to know what it's doing well on and what it's doing poorly on. So we at Snorkel do what's called slicing your data. Again, we're back to the labeling function thing. Again, I'm not trying to sell the platform. If you buy the platform, lovely. Credit me when you have that conversation. All of this applies outside of the platform. It's harder to do outside of our platform, but all of these ideas are universal. So what we do with slicing the data is we label prompts. So we have you have your set of 100 prompts, 200 prompts, however many prompts you need for your test set, and you label them as being in different kinds of tasks. So in this example, we have disputes, administration, toxic questions, Spanish, and then no slicing overall. And by slicing the data like this and evaluating slice by slice, you start to see the problem. 75% overall accuracy, 45% on disputes. If you're only looking at this top line chart, you're not going to see that. You're just saying like, oh yeah, the model's doing well, let's move on. You start slicing it, you go, oh wait, no, there's a problem. We need to address this. And this graphic in the middle, you can imagine each of those as your data points, and you're just kind of drawing lines around them. Actionable. Actionable. You got to be able to fix a problem after you find a problem. Very basic. Find error, fix error. Find error, fix error. And let's take a step back. You all, I hope, know that these systems are usually pretty complicated. There are many parts to them. The LLM is just one item, right? Most of these systems are going to have retrieval augmentation. That RAG system is going to have an embedding model. There might be a re-ranking model. You might have a screening model that's looking for jailbreaks or other things like that. You could have 15 components and 7 models. That's probably on the high side, but you could have that many. So when you're getting a bad response out of your model, you need to localize it back to where that bad response is originating from. So if you start looking in your prompts and you go, oh, we don't have, the context isn't there. We're not giving the model the context it needs to answer this question. Well, check out your vector database. Is that data in the database? If not, load it in. Maybe that solves the problem. Oh, well, it's in the database, but it's not getting retrieved. Well, now maybe your embedding model is wrong, because an off-the-shelf embedding model is generally going to work for general knowledge. But you don't have general problems, you have specific problems, you're working in a specific domain, and it might cluster your information too close together, and create a noisy retrieval problem. Okay, you got your RAG figured out, but you're still getting the wrong responses. Well, Now you have generation. Now you fine tune your LLM. You give it high quality prompts and responses to train on, to fine tune on. And this might involve creating new responses by hand, which nobody really wants to do, but sometimes we have to. But it also might mean just filtering better, like getting bad responses out of your training set. And then this last bucket is updating your items that you're using to judge your model. So this is the only view that we're going to have in the Snorkel flow. I don't want to, again, this is not a product pitch, but this is what we have in Snorkel flow for our LM evaluation suite. So up here, this line chart, this is your iterations of the model over time and your different evaluation metrics. So you can see as you're going to the right, you're getting better. That's what you should hope for. Doesn't always go that way, but generally that's how it should go. And then down here, we have our slices on our y-axis. And over here we have, and this is a little confusing, we have our different model iterations, and we also have our evaluation metrics. So here we have our elements judge, here we have our quality model, we talked about that earlier, and here we have our ground truth. And in this view, we are comparing two versions of this model. So here the model is doing better, here the model is doing worse. And the thing that we do within the platform, and again, you do not need to buy this platform. If you do, tell them I sent you. You can click into any of those and see what responses came through that shouldn't have come through. You can get directly into the data that is going wrong and see where you can dive in. And again, all of this is doable outside of the platform. You need some system to do this because once you've spotted the problem, you need to fix the problem. So I now need to say specialized, fine-grained, and actionable another, I said 50, so I'll stand up here and say it's 10 more times. So you need to evaluate according to the things that you care about. You need to evaluate on the tasks that you care about, and you need to be able to fix problems when you find them. So specialized, fine-grained, actionable. Thank you very much. Applause, that feels great. If you want to reach out to me on LinkedIn or email, go for it. I understand we are going to take, oh, I see a question over here.
Good experience in medical AI.
Okay.
And I must tell you that the LLM as a judge, it's not good in medical AI.
So the off-the-shelf, I'm certain you are correct on. And it is possible that there are corners that this approach will not work on, but I suspect that if you spend the time with your subject matter experts to customize this aggressively, it will never be as good as your SMEs, but it should be able to serve as a better proxy.
The judge is the applicability, if it's actionable, as a contribution to the clinical model. Without this, there is no MVP.
I can't claim to know anything about the medical field, so I will take your word for it. You're not allowed to ask a question, you organized. You have a question?
I have a question. So I feel that there's a lot of domain knowledge for each step. So how do you work with the companies? Like I imagine you have a lot of time to get them to give you the domain knowledge, and then it's not enough, and then you go back to them and then they give you more.
Okay, this is a great question, and thank you for helping me make a sales pitch. So one of the main selling points to Snorkel is that it's a platform for data scientists and subject matter experts to work together. So in the classical flow, so what we're talking about here with the LM evaluation is a little bit different from our classical flow. The classical flow is you have the subject matter experts label a small amount of data, 100 rows or so, and as they label their data, you ask them for their logic on labeling that point the way they did. So then you take their logic and you turn that logic into labeling functions. And you implement that however it's. Maybe it's a series of if-else rules, maybe it's a cap on a continuous variable, maybe it's a string search, or maybe it's an external model. And this isn't, as if we go back to this view, this is an iterative process. You go iteration after iteration. We talk about it as AI data development. So instead of viewing data as a static artifact and the labeling functions as static artifact, you're iterating over and over until your model is doing as good a job as possible of reflecting the judgment of your subject matter experts. And this is by developing the data. Oh, one more.
Can you hear me?
I can, but this is for the Zoom.
Great presentation. You said that you are working with annotations and labeling. I was just wondering, what is the pipeline for storing that huge amount of data in VectorDB, I'm guessing, and then fetching it back? Are you using GraphRag or you are going by the basics? Just a little bit of enlightenment.
So that is a good question, but the answer is we don't really handle that part. We help at Snorkel, we help our customers. Let me back that up. We have done some more hands-on engagements with our customers where we build out the infrastructure for them. But in general, what we do is we help them build their models, and they handle their infrastructure for how they're going to store it. So they have it in Databricks or Azure or wherever, and it comes into our system. We do the labeling and then we push it back out. Okay, looks like it. Any last questions before I flee? Oh,
You mentioned about consistency before, so can you elaborate how do you measure the consistency of model? Evaluate that.
could you clarify the question?
Previously you mentioned if you ask about the city's president, right, there may be different ways to have it. So how do you measure the consistency of a model? I haven't seen you address that.
So the way that you would monitor or adjust?
Evaluate.
Evaluate. Okay, so accuracy is going to be evaluating accuracy is tricky, but it's generally going to probably involve some version of a string search to make sure the correct words are returned. Calculating based on the embeddings may also be useful.
Like consistency, how do we know that if I ask the same question 100 times, it's going to be consistent?
So that is really up to the parameters that you put into the large language model. So if you turn the temperature on the model way up, you're going to get less consistency. If you turn the temperature way down, you're going to get the most likely answer every time. And that's really up to what your organization wants to do. That's not something that you're going to handle through this interface so much.
We are from finance, so basically we always use 0 as a temperature. But
Yes.
still, it hallucinates, it's still not consistent.
So it should be, I haven't seen your specific deployment, but it should be consistent, right? Hallucinating is a different matter. So hallucinating, that's a thing that you can fine tune to try to eradicate. Also, leaning more heavily on RAG tends to reduce hallucinations. But in terms of consistency, if you're using 0 temperature, the response for each prompt should be approximately the same.
Got it, but we can talk offline.
Okay. Oh, I guess I'm still up here.
One quick question. So you mentioned about you can find errors as we have a mindful stuff. Yeah. So you mentioned that you can find out all the errors as you see that there is a difference between what the business owner thinks versus what the model is producing.
Correct.
Now, does your platform also help in figuring out where the errors are, or is it a purely manual process?
Oh, again, thank you for going right into the sales pitch form. So yes, how the iteration generally works, and then this was not a sales pitch for the platform, but if you want the sales pitch for the platform, how the process generally works is you go, okay, we're having trouble with this bucket, and I don't have the view from the platform that speaks to this directly, but we have a thing called it's not the confusion matrix, it's the clarity matrix. We have a thing called the clarity matrix that gives you the buckets that are doing poorly. Click into that bucket, and then you go, okay, what are we getting wrong? And then once you figure out what you're getting wrong, you go back to your labeling functions and you add new labeling functions to accommodate for what you're getting wrong. And like I said, iterate, you can do 5, 10 iterations and you'll get there.
Thank you.
There is another presenter.
So I have a relatively basic question. So for all the evaluation you mentioned now, is that outside of the model training or inside model training? What I mean is like, for example, if I want to include evaluator in my model, so every time when the user asks questions, it will evaluate first and until it reach to a certain score, then return the results. Or evaluation mention is just before I train the model, and after that, I will just give the off the shelf model to the user.
I don't think I 100% followed that question. Let me see. You're asking about evaluation while the model is in production, or you're talking about evaluation during the development of the model?
I just wonder if I need to have any case to include the evaluation inside the model.
Short answer, we could help with that, but that's not a standard off the shelf thing that we do. We do. I think I know what you're talking about. You're talking about the models that run sort of alongside the LM that says, is this going toxic or something
And
like
when
that?
the model goes to the production, it still has evaluation inside.
That is gonna be a case by case basis. That's not a question I can answer. Blanket wise.
For your product, is there any something related to this case?
So we could help you train that model, that evaluation model that you want to run alongside your large language model. But we help you train the models and then you implement the models however you want. We're not that part of the stack. We're the data development part of the stack.
Okay, got it. Thank you.
All right, thank you so much, Matthew. That was a great topic and a great presentation. Next up, Mr. Steve, would like to have up.
No. All right, can everyone hear me?
Yes.
All right, not deafening? Okay, so my name is Steve Notley. Let me get back to my slides over here. Perfect. And I'm from Wallaroo AI. And today we're going to be talking about robust, effective, and efficient LLM operations. So this is a great segue from Matt's talk on model development and that data pipeline, where all of that information comes from. And today we're going to talk a little bit about what we see in the field about those models making their way into production and getting to the point where they are ultimately generating ROI, where they're generating value for the business, for your users. And so who we are. A quick intro on myself. I've been working in the ML AI space for about 8 years. Started in academia on the theory side, really around feature definition, and then made the leap to applied AI. And I've worked on applications around different use cases in a bunch of different industries, from finance, life sciences, ad tech, defense, and others. And what ultimately brought me to Wallaroo and to the topic that we're going to talk about today is that I really found that through all these different use cases, through all these different industries, there was one real recurring theme, which is that everybody has a hard time getting these models out of R&D. right? They always get to the exciting result, and then they have a hard time actually bringing that out to the world, delivering it to people, and delivering on the promises they've made to actually scale that up. And so here at Wallaroo, I lead the field engineering team, which is focused on understanding our customers, getting to know them from at a technical level, and then ultimately accelerating their ML and AI initiatives. And so what do we do at Wallaroo is really driven by this problem statement, that 90% of AI projects fail to deliver ROI. Let me go ahead and actually move this Zoom thing out of the way so that it's hopefully not blocking the screen. There we go. And so this is really, as I said, our problem statement, right? This is based on data that was published by Gartner, but really checks out with what we've seen talking with customers across different industries. And so, we've really spent a lot of time trying to figure out what those reasons are of why these initiatives kind of have a hard time making the leap from proof of concept to enterprise production grade inferences. And these are just a few of them, right? So ultimately that heavy engineering effort and specialized skills are needed, right? When you think about the skills you need to train a model to make sure that it's accurate, to really feel confident in those predictions, and then the skills needed to create a service, containerize it, make sure it's consistent, get it to serve, hundreds, thousands, millions of requests. Those are very different skill sets and very hard things to communicate, right? Some of it is the complexity and cost of production inference. Folks have a hard time right-sizing their hardware to the needs of their application. Another is poor monitoring and troubleshooting, really understanding how your models are working. And so those are the three kind of themes we're going to talk about a lot today. And then the last 2 points here, the fact that these workloads are exploding and that data is kind of spread across many disparate sources really compounds those problems and makes them acute for a lot of these different use cases. And that is a lot of the reasons why we see some of these models kind of not really getting to their full potential in production. And so how do we engage with enterprises to try and solve these problems? So we aim to help our customers prototype, deploy, and scale those AI initiatives in an efficient way. And we offer repeatable industrial grade ways to bring your models to production in a platform that helps you do these things. We're going to see the platform a little bit at the end, but as Matt said, we're going to talk a little bit more about the core concepts that are enabled and where we run into those in industry. And so that is around ML and AI in general, right? Across language, across vision, across all these different use cases. So what do we see actually when talking about LLMs, when talking about GenAI? And so really a version of the same thing, right? That we want to help you get to production quickly, find that optimal infrastructure, scale that up, and then monitor so that you can understand your models and intelligently iterate on them by tracking down what those problems are. And so what we've learned, how we're innovating based on the interactions we've had with customers on these topics. So the challenges here as they relate to LLMs, again, a microcosm of some of the bigger ones that we've seen with ML and AI across different use cases, right? The unrealized time to value and ROI, the engineering overhead and complexity, again, of taking these systems that work well in principle, and then it's a whole different skill set to get to scale. A big one is infrastructure cost and availabilities, right? Everyone is interested in how big of a model you can get, how much hardware is needed to power that, and how fast exactly you can make it run. And so that's going to be one of the bigger themes that we'll talk about today. And then, of course, security, compliance, bias risk. And so what have we found in terms of the best practices for effective LLMs? So these are kind of the 3 points that we've distilled down to, and you can think of it as speed, quality, quantity. Speed, right? How do you actually get to value quickly? And the important thing is really, LLMs and GenAI in general can be used for a very wide variety of things. It's important to test your hypotheses, right? To actually get it in the hands of your users, figure out what is the quality of the responses. Is it accomplishing those goals? And so what we find is that, coming in and working with customers, a lot of folks think, okay, my problem, it's complicated and I need to go straight to the 700 billion parameter model that needs like 1,000 H100s to run in my runtime. And what we actually really encourage our customers to do is, rather than start enormous and get small, start small and build up as you find a need, right? And so what we actually find is that the customers that we work with today, the ones that have LLMs there, that are publishing papers on it, that are making money off of it, that have like net positive gains from their LLMs in production, are not with these enormous models running on tons of GPUs. A lot of them are on, small models, 7 or 8 billion parameters that are even quantized to a lower value, running on CPUs and other commodity hardware. Let that sink in, because we've really kind of gotten to a world where he who accumulates the most GPUs wins, and how big can we go, how fast? And so we really find that it's important to take a step back, start small. And the customers that we've done that, you'd be surprised at the level that they get to and say, wow, we actually don't need more than that. This is performing well, we're getting good results, and we're able to do it at a much lower threshold there than we'd expected. And so I'd encourage you all to experiment and see what those results are. Get something at a small scale together and see how it looks. Once you do have it into production, and Matt made a lot of great points on this, it's really important to understand what your models are doing. And that's that second point that we have here, establishing tight feedback loops so that you have ways to monitor your models and get metrics around how it's performing. Now, again, as Matt said, with other models, there are well-established, well-trodden paths for quantifying how is it doing. With LLMs, much less so. It's much more subjective, and it varies a lot more use case to use case. So it's important to really sit down and think, what does success mean to me? How would my SMEs characterize success? And use that as a starting point to putting some of those intelligent monitors in place. And then finally, automating so that you can scale efficiently, right? And we really encourage people to build out LLM systems with very modular components, because it's such a fast evolving space, right? So I had just said, a lot of customers achieve success with a very small model. Maybe that'll be the case for you. Maybe you'll need to go through a few iterations before you find the one that's right for you. And so every time you change that, it would be great to not have to overhaul your RAG system, not have to have an entirely different set of monitors for the same use cases. It'd be good to be able to reuse as many of those bones as you can, so that you're not reinventing, you're not rebuilding the whole ship every time you need to change an oar, right? And so that, and building not just for the once, but for the vision of needing to deploy and redeploy this several times, maybe many, many times, is something that we always encourage with our customers when they're getting started on these initiatives. And so a couple of targeted areas where we'll see each of these. The first is another area that enables some of these small models to outperform is RAG. Now, who here is really aware of RAG and how that works? I suspect a lot of people. All right, awesome. Yeah, good showing. The short version of what RAG is essentially saying, hey, when you query this LLM, I know LLM that OpenAI or that Microsoft, Google, or whoever it is has trained you on, all of the internet, and you're able to get all of this information for me. And in addition to that knowledge, I want you to look at this very specific piece of knowledge that I'm going to give you, and I want you to weigh that more heavily to provide answers that are relevant, not just in a global context, but to my context. And so getting your LLMs into production with a RAG system that is loaded with context relevant to your use case is something that is going to allow those small models to overperform, right? To get those really strong results. And so this is something that we encourage our customers to think a lot about and to explore the most performant way to integrate. And with the Wallaroo platform, those, as you can see, are deployed as a pipeline. So one stage where you compute an embedding, and then another stage where that is used to query your vector database, form your full prompt and ultimately pass that to your LLM. And so that is one area where you can get a lot of, that is a big help in terms of the quality of the responses. An area where, as we get more into the speed of the responses, right? Okay, now I'm happy with the responses that it gives. I found a model that is efficient for my use case, that gives me good responses. How do I scale this and make sure that I'm using my hardware appropriately? And this is really most, in some cases, is most pertinent if you're hosting your own LLMs, right? If you're using a third-party, provider, a hosted endpoint. Some of this may be in your control, some of it might not be. But when working with customers who are hosting their own, we see a lot of really good performance with various libraries for quantization and acceleration. Particularly, we've seen great results with Llama CPP on CPU. Those customers that I mentioned getting lots of value out of CPU-based LLMs are really, a lot of them are using libraries, are using Llama CPP itself or libraries like it. VLLM also does a lot in terms of the acceleration on GPU. It's essentially a package that is used to, framework that is used to accelerate LLMs. Yeah. No. And so on the hardware side, two additional things that we find provide a lot of help is auto scaling. So essentially making sure that you have a platform that allows you to, based on the throughput that you see through your endpoint, making sure that it scales up to make sure you can meet your SLAs in terms of how quickly you respond to your customers, and making sure that it scales back down so that you're not unnecessarily using hardware that is not needed. And then the last thing is around dynamic batching, which is really this idea that a lot of LLMs actually perform very well on batches of data. And so as you have these requests coming in, if instead of firing them off responses one at a time, you can group them intelligently, have a batch-based response, and then divide them up and redistribute them out to your end users, you get a lot of performance gains there. And so the chart that you all see over to the right there really shows essentially not doing these things, in particular dynamic batching, versus much quicker response times when you have optimizations like this in place. And so all of these things kind of coming together really opens the door for how you can get these LLMs to be performant, how you can really host them yourselves, and how you can really get that high quality performance in maybe unexpected places. Now, the last piece I want to tie back is what we talked about with monitoring, right? And so we talked, we've already heard a little bit from on Matt's side about how it's important to get these quantifications that are tailor-made for you and informed by your SMEs. And we couldn't agree more. This is something that we all also often encourage our customers to do, right? Think about how to quantify those things and use that to really get down to a concrete metric for how well your LLMs are performing. And so with Wallaroo, we kind of really encourage two different kinds of monitoring and using those metrics. One is what we call the passive listener model, which is essentially what you see here, this idea that traffic will come through your inference endpoint, it will generate logs, and that then you have an army of these listeners, right? Each one corresponding probably to one metric or to a couple of related metrics that are then evaluated and then tracked, right? So that you can see things like sharp departures in those metrics as it sees real world data and things like that. And this will give you a macro level look of how are my LLMs performing and what trends am I seeing that are maybe concerning or that I need to address to inform things like, do I need to retrain? Do I need to augment my embeddings in my vector store? Now, the alternative to this, or not alternative, but a complement to this, is active listening. And I think there was a question about, can you actually bake these into this model, into these models to really output that to really output those scores alongside the raw model results? And the answer is yes, and this is something that we see customers do in practice, where instead of having this army of listeners operate offline and provide those macro level insights, you can also have them attached to the pipeline itself, run in real time before that response is sent back, and take some action accordingly, right? If it violates this threshold, do I want to stop this response from going out, right? An example that we see here all the time, toxicity, right? You don't want hateful language, and especially in customer service scenarios, being echoed back to your customers just because they may have not so kindly addressed your LLM, right? And so being able to catch that, say this flags a score, take some action, whether that be suppress the output, direct this to a human representative, or fall back to this other model, allows you to intervene in real time. And so those are a few of the key areas where we've really worked with customers to make sure that whether or not you're hosting your own LLM, you're able to get an idea of how it's performing. And in the case that you are hosting your own, you have a path to get to production, you have a path to get there quickly, and you can be sure that you're using your hardware and your infrastructure to the greatest, most efficient extent possible. And so I do want to take a moment to show you what this whole process end to end looks like in Wallaroo. And so this is an example where we have a general purpose LLM. We're going to take a llama in this case, and we're going to actually get it into production, get it packaged up, get it deployed, get it to scale, and see how we can monitor it. And so I have a video here that is a little small to see, but I'll stop and kind of explain some of the key points here. And so we have here a Jupyter Notebook environment. And so what we're going to do is, first of all, import our Wallaroo SDK. This is a normal pip installable SDK that I'm going to use to connect to my Wallaroo instance. We didn't talk about this too much, but Wallaroo is installed software. So this is going to live in your cloud of choice. And so we support all of the major clouds. This one is living in Azure. And so we essentially, from our development environment, connect to that instance, and now we're going to interact with it to deploy our LLM. Oops. Like this here. And so what we can then do is define the inputs and outputs of our LLM. And we can see here, I have my LLM defined. It's using Llama CPP. And we have our definition of my model in a separate file. And I therefore say I'm using the custom framework. And I say, hey, I'm actually targeting Ampere ARM CPUs for this. So I want to optimize for that ARM architecture. And so in just a couple of lines of Python code, Wallaroo is going to give me the ability to make sure that I'm automatically packaging up my model and taking into account any acceleration and optimization for a given architecture. I can then go a step further and actually specify the hardware. Sorry, I'm not sure. There we go. I can actually go a step further there and specify the hardware. And you can see here I'm attaching about 14 CPUs to this instance and 14 gigs of memory. And so what that's going to essentially do under the hood is say, great, I want to provision this and have every instance of this model have those parameters to work with. And Wallaroo will automatically provision that. It will go ahead and deploy your model on it. It'll spin up it'll stand up the service in front of it. It'll stand up a load balancer so that you don't have to worry about any of that. And it will stand up as many concurrent instances of your model as needed. And it will make sure to efficiently use whatever hardware you've given it at inference time so that you don't have to worry about making sure, well, did I utilize the extra CPUs that I gave it, et cetera. And so we can then essentially tie all of that together by calling the deploy function that we see here. And that takes, varies widely by model, right? For structured data models and things that are smaller, takes 20 or 30 seconds to actually do that process of package it up, provision the hardware, stand up my concurrent instances, et cetera. For an LLM of this size, so this is Llama 8 billion, we found it takes around 8 or 9 minutes. And what I'm left with at the end of the day is a model that As you can see here, we can ask it to describe what Microsoft does in a single sentence. We wait a few seconds, and then we get our result. And so if I'm happy with this, I then have this external URL that I can send requests to just like that and get that response back. And so what we have here is an LLM that I'm hosting myself in my cloud, running on CPUs. And if I'm happy with this result, I am in production, right? I have made that leap that we have talked about, and I have an endpoint here that I can distribute to my applications, that I can give to my customers directly, or whatever I need to do with it. And I can ensure that it is going to auto scale based on demand, and that I'm going to get these results in the most efficient way possible. Now, that is kind of in the weeds. We've deployed one LLM, we've gotten this result, and we've, we're in production. And so, now did this just start over? All right, let me see if I can get this to, sorry about that. Let me get this over here. There we go. Now we can hopefully fast forward here. Wonderful. So thank you sorry for the delay there. Thank you for bearing with me. And so once we're at the point where we're in production, this is off making inferences, we can zoom out to, this is not going to cooperate with me. We can zoom out to actually managing multiple of these models in production. So you can see here we have the Wallaroo platform. We have this particular version of our pipeline that's active. I can see the models in the pipeline. I can see the versions. I can see it running. I can see what hardware is powering it, control it by deploying it or undeploying it. And I can also see here the LLM listeners that we have monitoring this. And so in this case, it is a toxicity monitor that I have actively here and able to be managed in the exact same way. I can see recurring batch jobs that are actually going to go and say, hey, every day, aggregate the interactions that my LLM has had, run them through this toxicity score, and let me know how they went so that I can see, as we'd mentioned before, the aggregate of how this model is performing in production. And so I can see these individual runs. I can see when it was last evaluated. I can see the state of it. I can inspect logs or kick off a run of this here if I want to. Or I can go into my, my monitoring pipeline, and I can actually see our automatic diagnostics and what those results are looking like. And so this allows me to see, based on the baseline that I saw of my testing, how far has this departed from my acceptable baseline of these scores? And anytime I have one of these red dots, I essentially have a measure of what that score was, how far it departed from my baseline, when it occurred, and what triggered that I can then use to examine and get an idea of where my model might be failing. And this will help me take that action, the actionability of being able to go ahead and drill in to, augment my vector database, fine tune my model, whatever it may be. All right. And that is what I really had to show here today. A couple of resources that I wanted to link to. Our documentation site has a lot more information, a lot more details on the things that I talked about today. I showed a quick demo here today, but we have longer demos on a variety of topics. So if you want to see more, you can request a demo at this link. And last, get in touch. This is me. Please shoot me an email anytime. I love to have conversations with customers and with folks just interested in this kind of technology about what y'all are working on and how we might be able to help. So thank you very much, and happy to take questions.
Take questions now.
Hi. Does Wallaroo AI integrate with other guardrails frameworks such as guardrails AI to enhance model safety and reliability?
Yeah, absolutely. So we have a very open-ended framework in terms of what you can use as a guardrail. We have a bunch of off-the-shelf ones that are more generalizable that we work with our customers on, that we go ahead and roll out. We also, and even more commonly, work with our customers to define what is a reasonable guardrail for you. As Matt mentioned, that's always a little bit different across different use cases, across different industries. It's important to understand those SMEs and work closely with them. We're never going to be able to create a metric like someone who really understands the depths of your use case and your industry. In terms of that particular company, I'm not familiar, but we have worked with third-party companies in the past to integrate those systems. So yeah.
Can you share some example of use cases or industries where Wallaroo's age deployment capabilities have been particularly impactful?
Great question. So edge deployment specifically, you had asked. So a big one there that I'm allowed to discuss is actually with the government. So we work with the Space Force, and we've actually deployed models to orbit, to satellites. And so we've had edge deployments that we've taken from the lab, from various environments there, and actually then taken that to devices out in the field and ultimately to a satellite in orbit. So that's actually something that we're working on right now in terms of kind of getting the full ecosystem to be available in the very extreme edge of space. But that's a really exciting project that we've worked on, and a lot of different models there, some language, but a lot of that is vision focused. But yeah, edge is a super exciting area, and we love doing work in that space too. Awesome. To that question, any other questions I can answer? Yeah.
For your presentation. My question is going to be about listeners orchestration.
Yeah.
How do these models adapt to the new evolution of language? Take as an example the use of words like language is always evolving. How to this adapt and integrate with all the logs that toxicity have to measure?
That's a great question. It's a really good question because MLOps is something that is layered, right? So we're talking about here using models to score other models. And so that is part of the operations of your LLM, but those individual models, they're going to have their own MLOps lifecycle too. And they'll need to be retrained on the latest data as well. And so a lot of these models are foundational. They're much smaller, right? They're easier to retrain, and they hopefully don't have to be retrained as often. But yeah, to capture evolution in language and really evolution in other concepts as well, those will need to have their own kind of MLOps life cycle, and that's something that we definitely encourage and see with our customers. Awesome. Any other questions? Something just beeped at me. I don't know if that means I'm in trouble.
So is this open source in any way, or is it platform that's kind of fixed and that?
Yeah, so the platform itself is not open source. Relies on many open source components, but the platform itself is not open source. A lot of the models that we work with, including some of the listener ones, are open source.
So what is it based
on? The platform itself? You're talking about in terms of programming language? Or based on in what sense?
For the data pipeline.
Oh, I see. And so, yeah, so what we essentially we're a platform that allows you to essentially take various kinds of models, right, across language, across vision, across other use cases, and really automate everything that comes in between having this model that is trained, tested, and validated, and getting that kind of production level endpoint stood up. And so in terms of what data is based off of, right, we're kind of working with customers to get their own models into production more than training them ourselves. We do provide some of the listeners, and a lot of that is based on various open source data sets and some closed source ones as well. But
Data pipeline,
sorry, what was that?
the data pipeline, so what is it based on?
Oh, the in terms of just like how we move data through the pipeline you're talking about?
Or what's the data pipeline software?
Oh, I see. So we wrote our own, and so it's written essentially in Rust is essentially what handles our underlying compute, our data transfer layer, and ultimately our parts of our evaluation engine as well. Absolutely. Any other questions? All right. If not, thank you so much. It was great hearing from you all and looking forward to chatting more.
Thank you, Steve. That was a really great talk. We are getting to the end of the event.